Okay, so looking at this, last time we talked about simplifying radicals. Today we're going to look at multiplying and dividing. You're going to find that it is very, very similar to what we talked about last class. So first we'll look at these two fractions. Same kind of idea as last class. Hopefully most of you can tell me that 3 times 10 is 30, 4 times 9 is 36, so that's 30 over 36. That's not really the point of these problems, though. All right, going to walk through these problems with kind of the same process that we're going to walk through the actual problems in the notes. Okay, so first thing again, I'm going to need to factor those down. Now 3 is prime, so I'm going to leave that alone. But I can break 4 down into 2 times 2. I can break 5 down into 5 times 2. I can break 9 down into 3 times 3. So I want to factor it down as much as I can. And everybody look up there as I do this next part, because I'm going to take it away. Whenever you're doing these multiplication problems, even though it's got that multiplication in there, you can, whenever you're looking to cancel stuff out, you can treat this problem as if that is just one big fraction. Okay, so if I'm doing this and I'm looking for stuff to cancel, does anything cancel out?
Yes.
What?
1, 2, and 1, 3.
Okay. I can cancel those out right there. And now I just go across the numerator and I multiply everything I've got, which up there is just a 5. I go along the denominator, I do the same thing. 2 times 3 is 6. So it is 5/6. On the next one, I am dividing fractions. Does anybody remember what you have to do whenever you're dividing fractions? Do what? Keep, change, flip. Okay, so that means I'm going to keep the first fraction. I'm going to change it to a multiplication problem. And I'm going to flip the second fraction. The nice thing about this is most units, whenever we're doing all 4 basic operations, you kind of have 4 different processes in a way. And whenever you're dealing with this, division is essentially the same as multiplication. You just have to do that first step. And now it's the same as the previous problem. So I'm going to do 2 is prime. I can break down 9 to 3 times 3. 3 is prime. I'm going to break down 8 as 4 times 2. Daniel, can anything cancel? Okay, 3s. What else? And the 2s. So in the denominator, I've got 3 times 4, which is 12. What is my numerator now? 1.
So the first one, it's just the...
If you look over here in the rules that they have, okay, there's one typo. All right, this BD, and right here it says BC. Just change that C to a D, please. Okay, so that just kind of breaks that down. You're still going to have to find the restricted values. It's the same process as simplifying. It's just with simplifying, you only had one fraction. Here you'll do it for both, essentially. Because like I said, the multiplication problem, you can look at it as one big fraction. So let's look at A. And even though I just showed you that process, we're going to use that more so on B and C. We could easily do it on A, but there's an easier way to do A, so we're going to do it that way. Because I could write out 6 as 2 times 3 times x times x times x, and then 2, 5, and 3 are prime, so I wouldn't really write those out. But how I would do this is I'm just going to multiply across. And I'm doing this differently because they're all just one term. So I've got 6x cubed times 2, which is 12x cubed. And then I've got 5 times 3x, which is 15x. So on this, I'm just going to multiply them, and then I'm going to simplify it. Or reduce it, whatever you want to call that. So 12 over 15. And I want you to take it piece by piece. So first we're just going to do the coefficients. I can reduce 12 over 15 to what?
4 and 5. Or 4 over 5.
Yes, 4 over 5. I can divide both of them by 3. Before we write that, backtrack with me real quick. I forgot to mention one thing that you definitely need to know. To find the restricted value, if I take the denominator and set it equal to 0, but if that denominator is always just one term, what's my restricted value always going to be? 0. Okay. So on these problems, that's going to be your restricted value. All right, now like Jacob already said, I can reduce that. That's going to give me 4 over 5. And now I got to deal with the x's. And if you need to, and I have absolutely zero problem with this, let me just get a smaller arrow. If you need to, you can rewrite x cubed as x times x times x. If visually you need to do that. Because how many of those x's can I cancel out? 1. So how many x's do I have left over? 2, so it's x cubed. X squared, sorry. Alright, so hopefully not too difficult, but that's how I would approach those. I think it's a little bit easier doing it that way. So looking at B, this is B and C are more along the lines of the kind of problems you're going to see in this unit. So first, factoring my first fraction. I've got 1 times negative 6, which is negative 6. What factors of negative 6 add up to negative 1? Nope.
3 and 2.
Okay, 3 and 2. Which one needs to be negative? The 3. How can I factor the denominator of the first fraction? Greatest common factor, which is what? 5. Can I factor anything in the second fraction? No. 5 is prime. X minus 3 is a linear factor without a greatest common factor. So now, looking at this, Daniel, what are my restricted values? Okay. What else? Nope. Does that help? Positive 3. Okay, you're just going to go all the way across. Remember, if you got this 5 isn't going to do anything for me because there's no x to it. It's not 5x, it's just 5. Jeremiah, what will cancel? The x minus 3. Anything else? The 5 will cancel. So I'm left with x plus 2 over x plus 1 as my answer on it. Alright, I'm going to get the next one started for you. I'm going to do the numerator. Then I want you to finish it up. So x squared minus 4 is going to give me what two factors? X minus 2, x plus 2. And then the numerator of the second fraction, I can't factor. Let's go to the bottom 3. So Somebody tell me, what is the first thing I need to do on D?
You gotta keep changing flip.
Keep, change, flip. On division problems, that is the biggest mistake. People will just get in the habit of doing the multiplication process, and they will completely forget. And then some people, and I was guilty of it with my first class yesterday, they'll change it to multiplication and they'll just rewrite the second fraction. Make sure that you flip that. So these are all one term. So I'm just going to multiply across and simplify it. 2x to the fourth times 4 is going to give me 8x to the fourth. 7 times 35. 7 times 5 is going to give me 35. And then x to the fourth. What is my restricted value? What? 0. 8 over 35. Can I simplify that? Or reduce that fraction? No. I can't divide 35 by 8. I can't divide 35 by 4. I can't divide 35 by 2. But I can get rid of the x to the fourths. So my answer is just 8 over 35. Let's jump to F. Let's do F because it's a little bit different. They're linear. You've got this one part of it that is a single term and the rest are two terms. So we can't do, we could do this the way we did D, but I think it makes it a little more complicated. So let's do F, then I'm going to have you do E by itself. He's probably the easiest one of these three. So I'm going to keep my first fraction, but I'm going to go ahead and factor that 2x plus 6 into 2 times x plus 3. And then I'm going to also, whenever I flip, I'm going to go ahead and reduce the 4x plus 20 to 4 times x plus 5. What doesn't work?
10 is divisible by 4, so. Oh, it's 20.
Good? Okay. Alright, so looking at this, what is my restricted value? -5. Does anything cancel? The x plus 5s. And this next part is why we're doing this together, because this is a little different. Do I have anything else that can reduce? Do what? 4 over 10. 4 over 10 can reduce to what? 2 over 5. So I'm going to leave, and I'm just going to go ahead and rewrite it here. So I've got 2 times x plus 3 over 1, because everything down there canceled. And I'll go ahead and keep it as a fraction. Times 2 over 5. Now 1 times 5 is 5. That's pretty easy. But the numerator, I got to multiply everything together. Okay, the easiest way for me to do this in my mind. First, does it matter which order I multiply these three things together? No. Okay. So what is 2 times 2? 4. And if I distribute 4 into this, what's that going to give me? 4x plus 12. And there's my answer. Once you have that, I want you to go ahead and attempt E.